Hello, my name is John White. I now live in a small town in Mexico. Today I'm going to explain to you how to play the games called the Maya Cosmic Number Puzzles. They are found on Google Play. You need to type in the full name to bring them up on your computer. At the present time, September 2013, we only have them available for the Android system of smartphones and tablets. Later we will have them available on regular PC computers and then for the Apple system. These puzzles were originally found inside a Maya pyramid in the late 1940s of the last century. They were lost to the world for over 1,400 years. The original puzzles were inscribed on solid gold plates. Someday in the future we hope to show them to you, but for now we only have 2 of them to show you. Today, I want to show you how to play the games. There are more than one type of game. We will show you the 7x7 version today. That is this version here. These puzzles are for people who already know how to play the game. We have puzzles to start with that are 5x5, and if you are unfamiliar with how to play the game, there's where you should start. We have them available on the Android system at Google Play. Be warned, even these 7x7 puzzles are hard to solve. There are more videos posted on YouTube there are more videos posted on YouTube of the other versions of the game. There are versions of the 5x5s, 9x9s, and 10x10s at the present time. On our Facebook page, for our friends, we send out a free puzzle for 90 days. So please go to Facebook and type in the name of Maya Cosmic Number Puzzles or use the link below. Like us and enjoy some free puzzles for 90 days. At Google Play, we have over 45 books. They are priced at low prices for everyone to be able to buy. There is one for free for you to check out and see if you like the puzzles. These puzzles were used by the Maya people to help improve their brains. After solving several of the puzzles, you will notice there is a definite ability on your part to solve problems faster. Later, we will have versions of the games of 11x11s, 13x13s, and 15x15s. As you can see, they get very complicated. Today, we will be showing you how to play the numbers you are most familiar with in school. The numbers used in the 7x7 version vary. The numbers in this puzzle are from 1 to 7. In other puzzles in the same book, you will find puzzles that have the numbers from 0 to 6, and then from 2 to 8, and then from 3 to 9. To start with, check the puzzle to see which numbers you will be working with. This puzzle has numbers from 1 to 7. Next, read the rules of how to solve the puzzles in your native language. We also have over 40 languages available on the Android system, so it should be easy for you to understand how to finish the game. First, I start with finding the least amount of blanks in a row or column. In this column, we have 4 blanks or cells that are blank. That makes it pretty hard to solve for that portion of the puzzle. In this column, we have only 2 That makes it fairly simple to start there. In this column here, we have only 2, another good place to start. On your tablet or smartphone, you have the ability to select the help feature. It lets you see if a number has already been used. You can turn it off or on. I'm going to show you how to solve this 7 by 7 puzzle. It's composed of 7 rows and 7 columns. The Mayan system is composed of circles, dots, if you will, and a bar. The one circle represents 1, 2 circles represents 2, 3 circles represent 4, 4 dots represents a 4, 5 is represented by a bar, 6 is represented by a circle and a bar, 7 is represented by 2 circles and a bar. So today we're going to start with this column. It has 2 spots available that are blank. We're going to start with the right-handed column, and that is called the ones column. The other side is called the tens column in our vernacular. But we have, in this instance, we have a 4, we have a 6, we have a 7, we have a 1 and a 5. We are missing the 2 and the 3. If we look over at this row for doing a check, we notice that we already have a 3 in this position here. So if we have a 3 here, we cannot have a 3 here. That means that we can only have the 2. If we have the 2 in this position here, that means the 3 must go in this position here. Then solving for the left side, we have a 6, we have a 5, a 7, a 3, and a 4. We're missing both a 1 and a 2. If we check our rows, we see that we have a 2 in this position here. So if we have a 2 in this row already, we can not have another 2. So a 1 must go here. If the 1 goes here, 2 must go here. Now we have this column here solved. Next we will go to let's solve for this row where we only have two cells that are vacant. On the right side we have a 1, we have a 5, a 3, a 6, and a 7. We are missing both a 4 and a 2. If we look down this column here, we already have a 2. So the 2 cannot go in this position, only a 4. If the 4 is in this position here, then only the 2 can go here. Solving for the left side, in the tens column, we have both a 4, a 1, 7, a 5, a 6. So we are missing both the 2 and a 3. If we look down this column here, we see that we have a 3 in this position here. So we cannot have another 3 here. That only leaves us with a 2. If the 2 is here, then only a 3 can be in this position here. That solves for that row. Now, let's look around and see what else we can solve easily. Let's try this row here. On the right side, we have a 7, a 6, a 2, a 3, and a 5. We are missing both the 1 and a 4. When we look down this column, we see that we already have a 4 here, so only a 1 can go in this position here. If a 1 can go there, then the 4 must go here. Solving for the left side, we have a 3, we have a 6, a 2, a 4, and a 7. We are missing both the 1 and the 5. If we look down this column, we see that we already have a 5. So if a 5 is already in this column, at this spot here, we cannot have another 5. We can only have the 1. If the 1 is in this position here, then only a 5 can be in this position here. That solves for that row. Next, we look around. And we're going to solve for this row here, which only has 2 spots. On the right side, we have both a 4, a 1, a 6, a 2, and a 7. We're missing a 3 and a 5. When we solve for this row, we see on the right side we have a 4, a 1, a 6, a 2, and a 7. We are missing both a 3 and a 5. When we look at this column here, we see that we already have a 3 here, so only the 5 can go in this position. If the 5 is here, then only the 3 can be in this position. Solving for the left side, we have a 4, we have a 3, 2, 7, and a 1. We're missing both the 6 and a 5. If we look on this column here, we see that we already have a 6 in this position, so we cannot have a 6 in this position. That leaves only the 5. If the 5 is here, only a 6 can be in this position. that solves for that row. Now, let's solve for this row. On the right side, we see we have a 5, a 2, a 4, a 3, and a 6. We are missing the 7 and the 1. If we check, we see that we have a 6, 2, 3, 5, and 4 in that position. That does not help us. We have a 7 here. So if we have a 7 here, we cannot have a 7 in this position. So that must be the 1. If we have a 1 in this position, that means the 7 must be in this position. Now solving for the left side, we have a 2, we have a 6, we have a 3, a 1, and we have a 4. So we are missing both a 5 and a 7. If we check this column here, we see that we already have a 5 here. So only the 7 can go in this position here. If the 7 is here, then only a 5 can be in this position here. That solves for that row. Now, let's solve for this column. On the right side, we have a 3, a 6, a 5, a 4, and a 2. We're missing both the 1 and the 7. If we check, we do not have we have a 6 and a 4, which do not help us. We have a 7 here, which means if we have a 7 here, we cannot have a 7 here. So that means that only the 1 can be in this position. With the 1 here, that means the 7 must be here. Solving for the left side, we have a 7, we have a 6, a 5, a 3, and a 1. We're missing both the 2 and the 4. When we check this row for confirmation, we see that we have a 4 in this position. So if we have a 4 here, we cannot have the 4 in this position. So only the 2 can go here. If the 2 is here, we cannot have anything but a 4 in this position. That solves for that column. Now, we only have one blank in this column, so that makes it fairly easy to solve for. On the right side, we have a 6, a 5, a 1, a 4, a 2, and a 7. We are missing only the 3. On the left side, we have a 7, a 1, a 5, a 4, a 6, and a 2. Again, we're only missing the 3. Next, we look around to see what else we can solve for. Let's try this row here. On the right side, we have a 3, a 1, a 7, a 2, and a 5. We are missing both the 6 and a 4. If we look on this column, we see that we have a 1, a 7, a 3, and a 5. That does not help us. If we look over in this position here, we see that we have a 2, a 5, a 7, and a 6. The 6, if it's in this position here, we cannot have another 6 here. So that means only the 4 can be there. If the 4 is here, that means only a 6 can be in this position. Solving for the left side, we have a 3, we have a 2, we have a 7, a 4, a 6. So we are missing both a 5 and a 1. When we look at this column here, we see that we have a 1 in this position here. So if the 1 is here, a 1 cannot be here, only the 5. If the 5 is here, only a 1 can be over in this position. Then, looking around on the board, let's solve for this column. On the right side, we have a 1, we have a 6, a 7, a 3, and a 5. We are missing both the 4 and the 2. When we look over here, we see that we have a 4. So if the 4 is here, 4 cannot be in this position, only the 2. If the 2 is in this position, that means only a 4 can be in this position. Solving for the left side, we have a 4, we have a 1, we have a 3, a 6, and a 2. That means we're missing both the 5 and the 7. If we look over on this row, we see that a 5 is in this position, so that means the 5 cannot be here. That means only the 7. If the 7 is here, that means only a 5 can be in this position. Now, we look around and we see that we only have 1 blank in this spot. So let's solve for this row. We have a 4, we have a 7, we have a 2, a 5, a 3, and a 6. We're only missing the 1. On the left side, we have a 7, a 2, a 1, a 4, a 5, and a 3. We're only missing the 6. Now, that leaves a fairly easy puzzle to complete with only, in this column, 1 blank, in this column, only 1 blank, and in this column, only 1 blank. We'll start on the left side of this puzzle. The numbers on the right side are 7, a 2, a 4, a 6, a 5, and a 3. We're only missing the 5. On the left side, we have a 6, a 4, a 1, a 2, a 7, and a 5. We're only missing the 3. Now we could solve this column, and then we could solve for this column. It would be fairly simple. But let's go ahead and try to solve it in this row. We have a 2, we have a 6, we have a 7, we have a 4, and a 5. We're missing both the 1 and the 3. So when we check, we see in this column we have a 1. So if we have a 1 here, we cannot have a 1 in this position. Only the 3 can go there. If the 3 is in this position, then only a 1 can be here. Now solving for the left side, we have a 5, we have a 7, we have a 4, we have a 6, we have a 3. So we are missing both the 1 and the 2. If we look in this column here, we see that we already have a 2 here, so we cannot have a 2 in this position. Only the 1 can be there. If the 1 is here, that means only a 2 can be in this position here. That solves this 7 by 7 puzzle. Each of these puzzles have a difficulty level down here represented by the Mayan spirit Zapaknu. This is a difficulty level of 1, a very simple puzzle. In this position here, we have the time and we have the date. That will help you keep track of your improvements over the course of solving these puzzles. Down here, we have the serial number. The 707 represents that this is a 7 by 7. The 109 represents that this is in book 109. Thank you for your time. Hopefully you will enjoy the work that we have completed. Go to Google Play for looking at the different puzzles that we have available for sale. Thank you.